Right, I've got my reference card in again, and now I've repaired the power supply again. I powered it up and I saw smoke over here, and it looks like that tantalum capacitor right there is going up. I saw smoke from right here, and this tantalum's discoloured. So I'm going to power it up again and see if it appears to actually do it again. It's going to verify as well that my cards are seated correctly, but they should be. Alright, so let's power it up again, see if anything happens. See if there's more smoke. So it's that one right there. Not see anything yet. It may have cleared its own fault. It was on for a little while before. I don't know, a minute or two. Probably a minute before anything showed up. I was doing some other voltage checks. Yeah. Nothing so far. Might have missed the smoke. That's a shame. Oh no, I think I can smell something. So what I was actually trying to do was test the voltages. There we go, smoke. See it? There you go. Yeah, I was trying to test the voltages over here. Anyway, there's the smoke. So I think the tantalum's had it somehow. Obviously now I beefed up the power supply. It can do that. So, right, at least I found another problem. Alright, so as you saw just now, the tantalum capacitor smoked. I've replaced it. I haven't tried anything else yet. I've only replaced it. It's C33, which is right here. Okay, I'll get a bit closer for you so you can see it. There you go. It's right there. C33 in between those two inductors. Now, the next thing I was worried about is that this capacitor is on a trace in between these two op amps. So I thought, well, if that's been shorting out, it could have damaged an op amp. So that's something I need to check for. If I go to the schematic diagram and I'll show you where this capacitor actually is. There it is here. Right, C33 is there. F1 supply and minus 15 volts. So that's a floating supply it's connected to, and a minus 15 volt float, which is the power supply section I just repaired. So again, yeah. So that was shorting out across the supply. So it's probably, these are probably okay. I'll need to do some testing, but just to verify these op amps are actually working. I expect that they are. But that's the actual power supply output, goes to the reference AC/DC converter, and that's the supply I'm trying to measure in order to confirm that it's actually working. I also need to measure at it's ground, so I need to measure here TP3. Right, so I need to measure TP3 voltages to see if that's actually matching well, it's changing with the set voltage levels. Or was it set frequency? Something like that, I can't remember. Something changes it. Where is it? Hold on. No, it's not diagram, it's the next one down. The other side of T2 comes in, which is over here. Over here, so it comes in from this section here. And it has all this lot driving it. So I'll zoom out slightly. Alright, so it's got all this stuff driving it. Amplitude adjustment, so yes, so it's voltage control. So this should be providing a pulse which is relative to the voltage settings. And the idea there is that it will give a proportional voltage output. That's the theory. I haven't tested any of this, but yet I have tested the 10 MHz clock that is working. I've confirmed that already. That's working. TP1, I do have a 10 MHz clock, and that's fine. So I'm happy with that part. But so none of this is tested yet. What I'm trying to do test here is to measure the voltage on the other page, which I showed you just now over here. Alright, I need to measure here at TP3. So that's what I'll be doing next. Okay, so as you can hear, I've got the unit running. I'm hooked up the scope to the 10 MHz output, so I can show you that. I have adjusted the tuning very slightly. It was slightly off, but it's not. It's really touchy adjustment, so it's not easy to get right. Right now, it's bang on 10 MHz according to my scope. It's good enough for what it's just doing amplitude measurements anyway, so it should be fine. So that shows that's working, and I'm going to probe over here to show you the voltage output. So I've got this currently set. Yeah, let's do that. To 1 volt output at 1 kHz, operation mode turned on, and let's see what we get. Now TP3 is over here. What I found is that it's a little bit noisy actually at the test point, but if I come over here and increase the range, because I've got it turned up a little bit, got a manual ranging, there's a voltage there. That's the first time I've seen that. So and this is stepping, big steps on the, that's the 1 volt range, you know, the most significant digit. Okay, and if I go to the next range down, get it back on, I hope you can see that. And I change this one, see it stepping there as well, that's fine. That one there is stepping. Next one over is stepping. Right, next one over is stepping. Right. Anyway, which doesn't seem to step is the very least significant digit, but I think there was something mentioned about that in the manual. So the reference card, I can say, appears to be working correctly. Let's put this down to the lowest level it can do and see what voltage we get here. It's 0.276 volts. So yeah, not a problem there. And that's relative to the floating reference. I felt the back of the power supply there, and that feels okay. It's not getting warm like it was before. That's probably related more to the fact that I've removed the power amplifier card. I'm 100% sure that card's got faults on it, and I was probably just loading down the power supply and making it stress a bit, so I thought I'd just take that card out whilst I'm doing this testing. So that reference card seems to be working now. It's doing what I expect it to be doing. I haven't actually verified it against the manual to specify that, you know, what it specifies what you should be getting, but things are changing, so it looks like it is mostly functioning. So that's good. I think I'll probably look at the manual now and just do some comparisons and make sure it is actually working as it should be, and then I can put the reference card back together, put it back in the unit, and move on to the next card. Okay, so next thing I need to do now, I'm just going through the manual, just verifying a few more steps, is I need to adjust R48 to give exactly 7 volts output, plus or minus 10 microvolt. So we can do that. Let's turn this on, and R48 is that adjustment there, the reference adjust. I've already got the clip leads clipped on, and 7.01 volts, which is close. Now we want 10 microvolts, so it's that digit there we want, the accuracy there. So that's good enough. Let's get this thing on the adjuster. I can't quite see. There we go. What do we get? I'm not even going the right way. I wasn't seeing there. Oh, let's just get down here so I can see what I'm doing. Right. So we'll adjust that way. That's as far as it goes that way. It does mention about maybe not making it. Oh, there we go. It's going to do it. Right. So yes, it can be adjusted. Great. So let's go down. Oh. some more accuracy out of this. Might be going the wrong way. Yes, I am. Right. Slightly more, just about there. Do I need one more digit of resolution? Why is there never enough digits? That's incredible. So yeah, this I just bought this meter recently, and it's a 6.5 digit meter. Okay, and it makes you wonder if I need 7.5 digits now. Anyway, that's alright. It'll be fine. I'm pretty sure this is going to be close enough once I finish tweaking it. It's just a bit of a shame the first digit is wasted on a 0. Otherwise it would have enough resolution. Come on, there we go. I think I might leave it there. That's probably close enough. Alright. Right. So that's that voltage there set. So plus or minus 10 microvolts, and I've got, oh no, I need to go slightly more. What's that? Millivolts? Yeah, I'm on 10 microvolts pretty much. It's pretty damn close. So let's go slightly more. You have a bit of play in the adjustments. They've got a bit of slop in them, so. Once it's actually set, it's always, I think it's actually a good idea to back it off very slightly as well. Just otherwise it might unadjust itself. Yes, there we go. You could say I'm being a bit too concerned about the digits, but it may be relevant, so I'd rather do what the manual says and get it as close as possible. But yeah, one more digit resolution would have been good, I think, in this case. Right, I reckon I'm going to leave it there. There's a flicks another one up, I'm going to leave it there. Right. Some progress. Overload indicators on. Earlier that wasn't on. Anyway, and now it's changed. If I just unadjusted it, I've unadjusted it. Okay, hold on. Let me double check this. I'm pretty sure I've got this set wrong. 1 volt, 1 kilohertz, 1 kilohertz, 1 volt. Yeah, I didn't preset it correctly. It's supposed to be on certain settings on the unit. Firstly 1 volt, 1 kilohertz, which is what it's now on. Voltage error set it off, vernier set to 0. Now I'll adjust it again. It was still wrong. It means it's actually up by more than it was before. I think I need to go the other way. I do need to go the other way. But the overload indicator is on. Now, a little while ago that wasn't on. So that's a little bit interesting in itself. So close. probably isn't that exciting video watching me do this actually. But, yeah, I'll stop it in a second. This part anyway, probably not that interesting watching me do this. That's a little thing that, you know, pay attention to. You know, it caught me out is I hadn't preset the controls correctly, so that caught me out. So it's probably a good thing that you catch on video. Is that how you can make that little mistake? So it's got a little sweet spot just there. I'm barely even moving that. Okay. Done this time. I should move on to the next thing. Okay, so the next step here is to check this voltage. Where you put it on, see it actually just down there. There's a voltage error percentage switch. So times, you got times 0.1 off and times 1. So it says in the manual here to go to 0.1 and set R75, which is this one here, to 7 volts as well. So here we go. And this is plus or minus 20 microvolts. So this one should be a little bit easy to get right. Although it's not a multi-turn pot, so that might prove me wrong. This is a standard pot. Come on, turn. You notice I take my screwdriver off when I want to get the final measurement, because just having a screwdriver sometimes on a trimmer can affect its value. So I always take them off when I'm doing that final a little bit, just to get the value as close as possible. I've got a dirty spot on that pot actually, just chunked by quite a bit. Alright, it's 10 microvolts out. Is that close enough? Well, hey, there we go, bang on. Right, that's that bit done. Now I need some more calibration, which is step 25. Verify, yeah. Set the vernier to +3 and check for reading of 6.790. Is that with or without the voltage error switch turned on? Hasn't said to turn it off yet. Okay, well, let's do vernier to +3. +3 is that way. It's got a long way to go. Right, 2. +3. It's a little bit sticky. It's actually a little bit tricky to get it exactly where you want it. But there you go. It's +3, and it's supposed to be. I lost it. Where's it gone? .790. Well, it's near as damn it. Could just be the error in the vernier control. Just with the reading error. I mean, that's close, isn't it? It's yeah, it's like a fraction off. I'll say about 2.99. Yeah, 2.99. It's like 0.1 out. Yeah, or 0.01 out rather. Yeah, it's nothing. So that's that fine. I'll pause this and come back in a second. So the next one is to go to -3 on the vernier and make sure I've got 7.21 volts plus or minus 1 millivolt, and yeah, I'm only 330 microvolts out, so yeah, that's within spec, that's fine. So things are going pretty well so far. Now I need to do the same thing, go to x 0.1 or times 0.1 and verify for 7.021 plus or minus 1 millivolt. Yep, that's in spec, that's fine. I'm going back to +3 again. This vernier is a bit sticky, so I actually need to look at lubricating that, because it tends to bind very slightly, so it makes it's not smooth. So +3, plus a little bit more. There we go, +3, and for 6.979, plus or minus 1 millivolt, and that's bang on. So that's all working fine. So I shall carry on with this by myself, I think, unless I come across anything else. Okay, so a couple of other tests this thing asks for is to probe on U18 and check for pulses. So U18 is this one here, and check pulses on pin 6 and pin 18. Sorry, pin 6 and pin 8, and they all work absolutely fine. The pulses are correct, the correct timing, that's all fine. So the final stage is to check TP3 for the pulses there, and I'm getting the correct pulses there as well. So it should be what does it say? I've forgotten now. Hold on. For 10 milliseconds, 7 volt peak pulse, and then for 3 milliseconds, a negative pulse. So 7 milliseconds, 3 milliseconds. Was that sorry? 10 milliseconds, 3 milliseconds, and that's what it's actually doing on the screen there. So that's all fine. And that is the last step, apart from checking the RCU, the remote unit, the remote card, which I've currently got taken out, and I've got no way of interfacing with it. Well, I may have a way, but I don't have that kind of setup. I just don't do remote control stuff. So I've got a card, I can't actually test it. So that concludes the reference card. That is working correctly. That's all done. Job done on that one. Next video. Don't forget to subscribe, and maybe give me some money from Patreon, or PayPal, whichever. Patreon sort of at it now. It's all good. Bye. So I thought I'd show you this testing I'm doing on the actual individual voltage ranges on the Fluke here. I've got the STS1104XE set up for that. I'm only actually using one channel right now. I've got other ones hooked up, but I just want to look at this one particular thing right now. So this is the pulse width going into one of the FETs. So you can see it, this does by pulse width. So as you turn the knob, the pulse width changes and grows, right? So in order to change the voltage in that section. Okay, so I've got it zoomed in the bottom here, and that's the normal view there. Now, what I'm trying to confirm is that each switch position is working. So you can see that's growing there, so zoom in slightly more. So you can see it's growing. For each one, that's fine. Just want to zoom in a bit more on which bit is it? Which edge I'm looking for? Which edge I'm looking for? That edge. Right. Keep going on away with the zoom, because it goes. I expect it to move the zoom position, not the waveform. So it goes the opposite direction of what I expect, but that's just me. So I've got it zoomed in quite a lot now. So each step is changing. Okay, just very fine. Each one. See the one there. It's still changing, and go to the next one. Let's just bring this over a little bit and zoom in some more. This is the beauty of having zoom, is that you can get that fine details, keep getting right in there. Right, so there you go. Now it's changing as well. Let's move it over as well. Obviously, each switch position I go over by, the adjustment gets much more finite. So probably zoom slightly more there. Right, so there we go. So that just shows that each one is actually working. That's fine. Now the least significant bit isn't actually done through the system, so yeah, it's a bit different. But yeah, it's all working fine. I thought it was an opportunity to play around with the scope as well. My scope does the same thing anyway, but it's it's a chance to play. That's one. Yeah, so you've got a search function there. So on it.